All right, so in the last example you were given the standard deviation. Now we're going to work on how to calculate it ourselves. So the standard deviation of a sample. In this example, we have a table that shows the number of cars sold by an auto sales associate over an 8-week period. How much variability do the data show? So to find the standard deviation, let's just remind ourselves what the formula is. I'll write it over here. Standard deviation is equal to the square root of the sum of our data point minus the mean squared, all divided by the number of data points we have minus 1, because we're just doing a sample size. We only have 8 here that we have. Okay, so how do we break this down? First thing we want to find is the mean. So the mean, remember, is that x with a bar over it. We find that by adding up all the values. If you take 18 plus 25 plus 18 and add those all together, you're going to get 136. We divide that by the number of terms that we have, and we have 8 of those. So our mean is 17. So first step is find the mean. Done. Step 2, we're going to find the difference between each data value and the mean, and then we're going to square that difference. So this might be easier to set up in a table. So I might have to add on to this. So X is representing our data value. So I'm just going to copy that table from above. We have 18, 25. Actually, I know these are going to need to be longer, so I'll just do that now. We're just going to fill that in across the top. All right, so I just paused it to fill that in. Go ahead and pause and fill in if you need to. The next thing is we're just going to go ahead and write in what that mean was. So the mean across the board is going to be the same, 17. We're basically going to be doing math within each column, so this is just showing us what math we're going to do, or what numbers we're going to use for each column we have here. Okay, now we're going to find the difference between the mean, or between our data point, x, and the mean. So we're going to do some subtracting here. So all this is saying is what is x minus the mean? So what is 18 minus 17? We get a 1. What is 25 minus 17? 8. Oop. 8. 18 minus 17, 1. And we just go through and we do that subtracting. You will get some negative numbers. We get a negative 7. 17 minus 7 is 0. A negative 2, a 1, and a negative 2. Okay. So our next step is we are going to square all of those numbers. So we're going to take that last number, x minus the mean, we're going to square it. So all of these numbers that we just found, we square those together. So 1 squared is 1, 8 squared is 64. 1 squared is 1. Negative 7 squared, it will turn positive, 49. 0 squared is 0. We get a 4, 1, and 4. All right, so step 3. So step 2 is just kind of filling that in. Our goal was to get to squaring the difference between the data point and the mean. Step 3 is find the variance. So the variance is the mean of the squares of the differences between each data value and the mean. So the variance is going to be the average of these. This is the squares of the difference of the data point and the mean. So we're going to find the average of this last row right here. Oftentimes the variance is denoted with an s squared. Well, we're going to add all those numbers up. 1 plus 64 plus 1 plus 49 plus 0 plus 4 plus 1 plus 4. Okay, we're going to divide by n minus 1. So remember, we had an n minus 1 up above, and our n is equal to 8 because we have 8 values in our data set. So we are going to divide by 7. So when we add all those together, we get 124 divided by 7 gives us 17.71. We're doing a little bit of rounding there. 17.71 is the variance. Our last step is to find the standard deviation. So step 4, find the standard deviation, which is S. So let's just remind ourselves in our notes, that is standard deviation. Well, up above, we found the variance. Variance is S squared is equal to 1771. So to find S, all that we do is we square root the variance. So we're going to take the square root of 17.71, and that's going to give us 4.20883. And in this example, because we're talking about whole cars, you can't have 4.2 cars. We're just going to go ahead and say that's about equal to 4. So our standard deviation is 4. Nice job finding your first standard deviation. All right, so great, we found the standard deviation, right? But let's just, what were they actually asking? So let's go back to the example. It says, how much variability do the data show? So the standard deviation tells us that there is some variability in the data. So because the mean was 17 cars and the standard deviation is 4 cars, if we add 4 and subtract 4 on either side, we have 13 to 21. That means that that's 1 standard deviation away from the mean. Remember, that's a 34.1% of the data, 34.1%, and the data is cars. Cars are within 1 standard deviation of the mean. So if we do that math, we can expect that 68% of 68% of the time, the sales associate will sell between 13 and 21 cars. Okay, so let's look at this other question we have. Oops, all right, so I thought that would stay with that. We'll ignore. That's just, can I move? Oh, look at that. All right, get that out of the way. So the table shows the number of cars sold by the auto sales associate over the next 8-week period. So now they're looking at the next 8-week period. How did we do? How much variability do the data show? So I'll just give you some of the numbers. The mean for this 8-week period is 16.5, and the standard deviation is about 5.7. Now, on the last example, we did round that standard deviation to a full car because you can't have 5.7 cars. But we'll just leave that as 5.7 now, for now. All right, so because the standard deviation is 5.7, it's a higher number. That's showing more variance in the data. So if we think about, the mean is 16.5. And if we go 1 standard deviation in either direction, so if we add that standard deviation of 5.7 and subtract the standard deviation of 5.7, we're going to get about 10.8 on this side, and we're going to get about 22 0.2 on this side. So this is where we'll do a rounding. So 11 cars and 22 cars. So the sales associate can expect to sell between 11 and 22 cars, which is a wider range than the last example that had a smaller standard deviation. The last example was between 13 and 21 cars. This is between 11 and 22 cars. So a greater variance in the data with a larger standard deviation.